we're cooking now.
All right.
All right. All right, so you still see the variable screen here?
Yep.
Okay. Yeah, so variable names, they have to start with a letter, cannot have spaces in them, no punctuation. We're allowed to have numbers, they just can't be at the beginning, and they can't match a keyword in the language. So, for example, when you start dealing with asking questions in language, which is the second thing in our How Do Humans Solve Problems, we're going to be using something called an if statement. So that means that, for example, if can't be the name of a variable in Python and in many other languages. Okay, because if is a keyword that's part of the language. It's a reserved word in the language, therefore we can't use it as our variable name. Make sense?
Yep.
All right, so now that's the generic way that variables are defined. Now, to put this in context with what we were talking about up here, where we have compiled versus interpreted languages and things like that, I'm going to throw another slide in here. So just as a quick reminder here, we talked about there's two different kinds of programming languages. We have interpreted and we have compiled languages. All right, so compiled languages translate a high-level code into low-level code before we run it. Okay, we looked at a low-level assembly language version of Hello World last time, right? The Linux assembly. All right, so a compiled language does the conversion from a human programming language, a high-level language, into a low-level language before we ever run the program. Where an interpreted language does it while the program's running. So the ultimate thing is that an interpreted language is relatively slow, where a compiled language is relatively fast, considering that. But our computers are really, really, really fast, so it maybe doesn't matter in 99% of the circumstances. So, Python's a good example of that. Python is an interpreted language, which means it's relatively slow, but it also is true that Python's one of the most popular languages today.
Yeah.
Right? Because our computers are really, really fast, so it doesn't matter that it's relatively slow for a lot of tasks. Okay? So, we talked about interpreted versus compiled. Now I'm going to so here's some compiled languages: C, C++, Java, C#, Swift, Objective-C. So I usually call these our native languages. These are languages for producing programs for a specific platform. So we might use C or C++ for writing code for Windows or for Unix. We might use Java for writing code on multiple platforms because Java is kind of compiled and kind of interpreted at the same time. C# would be for writing stuff for Windows. Swift will be writing stuff for the Mac. You can say Java finds its best home on Android, writing Android applications. And Objective-C, it's a little bit older language, but it's for the Mac as well. So these are languages for a specific type of machine, rather than something that would run across multiple machines. Okay, where our interpreted languages will run on anything that has the interpreter for it. So, for example, Python will run on a Mac, it'll run on Windows, it'll run on Linux, it'll run on Unix, it'll run on any of these because there exists a Python interpreter for all these different platforms. You can write a Python program on your smartphone. So are you an iPhone user or an Android user?
I'm an iPhone user.
iPhone user. So if you went out to the App Store and you just did a search for Python interpreter, you would find Python interpreters out there where you could type in your Python code and run it on your phone.
What?
Yep, 100%. Definitely exists.
I should do that.
I had one of my grad students. I was having dinner with him, I don't know, a month ago or something like that, and he had a programming assignment in one of his other classes to create this thing called the Game of Life. It's kind of a known little game. It's kind of an interesting simulation. It shows patterns on the screen. And he said he had been working on it for like 20 hours or something like that. And so we were having dinner at this Vietnamese restaurant. So I downloaded a Python interpreter on my phone and I wrote his assignment on my phone during dinner and showed it to him. So that was pretty funny. But yeah, you can pull that stuff off. So if you're, wanting to, like, for instance, the assignment you did for today, that wasn't like, 1,000 lines of code or anything, right?
Yep.
So you could have written that on a smartphone, no big deal. And then once you get farther into programming, you realize that you can do quite a bit without tons and tons of code. So it might actually be handy sometimes to just write a little program that does something if you're trying to calculate something on the fly. That's just kind of a fun little thing. But you can find Python interpreters on iOS and on Android, and it's not because it's some sort of weird hack. It's because the Python interpreter itself is just a computer program that understands Python syntax. Okay, so what we give up in performance, we gain with portability. Okay? So you notice all these languages that are listed there as interpreted languages. Several of them you've probably heard of. You've probably heard of PHP?
Yep.
Okay, so web language. Ruby, you maybe have heard of that in terms of Ruby on Rails. That's usually talked about in that phrasing. JavaScript, so these are languages that are fairly common languages. Whether you know exactly what they're used for, they're things you've seen. All right, so punchline being these are popular languages, which means that interpreted languages aren't innately bad. They're just slower. All right. So in the context of this, I said we were going to have lots of slides that are kind of like this one. So this one says there's two kinds of programming languages, interpreted versus compiled. Now I'm going to create another slide that's going to be pretty similar to that. There are two kinds of programming languages. We have loosely typed and we have strongly typed. All right. Loosely typed languages do not require us to define the kind of value that a variable is built to hold.
Yep.
Whereas strongly typed languages do require us to define the kind of value that a variable is built to hold. All right? And then I'm going to, just to connect some dots there, I'm going to say loosely typed languages tend to be interpreted languages, which means they tend to be relatively slow. Whereas down here, strongly typed languages tend to be compiled languages, and they tend to be relatively fast. All right, so one important skill that you'll have over time, I mean, kind of right now you're in the early stages of becoming a programmer, so you're in the process of kind of collecting languages, right? So you've dabbled a little bit in a couple of things, but at this point, Python's kind of your thing, right? But, assuming you believe me, and the more we work together, I think you'll end up believing me more and more, that these skills you're learning today with Python will directly translate to other languages. It will be very beneficial for you to look at a language and try to pigeonhole it into what kind of language am I dealing with? Am I dealing with a strongly typed language or a loosely typed language? Am I dealing with a compiled language or an interpreted language? Am I dealing with an object-oriented language or a procedural language? We'll talk about that here in a few minutes. But, once you kind of pigeonhole the language you're about to work with into kind of its, where it fits in the world of languages, that's going to immediately give you a whole bunch of information about how that language likely works for certain things.
Yep.
Okay, now once you've been exposed to, at least one language from each of the different, let's say, genres, that would be more meaningful because then you can just sit down and start working with that language fairly quickly because you kind of know how it's supposed to work and how you're supposed to work with it and how do you compile it or interpret it and run it and all that stuff. Okay? Mm-hmm. So notice that this guy right here, loosely typed versus strongly typed, has a lot in common with this slide here, interpreted versus compiled. All right. So, for example, I can't name one language that is interpreted that isn't also loosely typed. Similarly, I can't name one language that's compiled that isn't also strongly typed. They kind of go hand in hand. All right. So to talk about the types then, we talk about variables here. I'll just do this in another slide, actually. So when we talk about a type, what are we really talking about? We're talking about the kind of value a container, I'll just put in parentheses here, variable is built for holding. All right. So now in a loosely typed, say loosely typed worldview, we might say if we're going to go to Target, for example, and we have a whole bunch of tax documents or pieces of paper or something like that, old homework assignments that we want to store. We're going to go to Target. We're going to get one of those big Tupperware containers, like a big storage box thing. We're going to bring it home. We're going to throw all of our old homework papers in it, and we're going to shove it under our bed, something like that. So in our mind, we've chosen to use that container to hold homework papers. But now, does anything keep you from saying, okay, well, I'm no longer going to store homework papers in there. I'm now going to store shoes? Can you just dump the homework papers out and then put shoes into that same container?
No.
Really? In real life, you can't do that?
Well, you can.
Yeah, in real life, you can do that, right?
I wouldn't.
Yeah, well, okay, maybe you wouldn't. So replace shoes with clean socks.
Yeah.
Replace shoes with clean socks. All right. So the point is that as a human being, when we go to the store and bring home a container, we can put anything in that container that we can make fit in that container, regardless of what it was built to hold. Right. So kind of the idea that comes in mind is in the entrance to my house, we have a little shoe bench thing that my wife uses for shoes. I view it as a decorative piece that I don't actually put my shoes in. But punchline is that particular thing was built for holding shoes, even though you could put anything into those cubbies that would happen to fit in them, right?
Yep.
All right. So that is a loosely typed worldview where when we buy a container, we can put anything we want in it day one, and we can change that up, any other day. Okay? So we buy a container, and what we put in it day one doesn't affect what we can put in it later. In a strongly typed worldview, we buy a container and we have to decide day one what it will hold. And it can only hold that kind of value from that day forward. So in a strongly typed world, if you decided to dump out those old homework assignments and you want to store clean socks, you can't reuse that container. You got to run back to Target and get a brand new container for holding socks, even if it looks just like the old one. Your old one can't hold socks. It can only hold those homework assignments. All right, make some sense?
Yep.
All right. So how this relates to variables. So we're going to say types in programming languages. All right, we're going to start with, I'm actually going to start with something called a primitive type. So primitive types, these are types built into a programming language that can only hold a value. All right, and I'm going to put a little note here because this is going to reference a slide for later on. So this is going to say, as opposed to object types, which can potentially do more. All right, so we're not going to talk about object types yet, but object types can potentially do more than primitive types. Primitive types' entire skill set involves holding a value. That's it. That's all it can do. All right, so to talk about our primitive types, I'm going to, have I shown you a picture of some of our old languages? All right, I'm going to introduce a picture here into the slides. I'm actually going to do it a little bit higher up. I'll just put it here, it's fine. So what I like to do, like I mentioned a few minutes ago, is kind of being able to pigeonhole where the language you're currently looking at fits in the world of programming languages can be beneficial. So I'm going to kind of draw you like the family tree of modern programming languages. All right. So right here at the top, I'm going to put this language called C. Have you heard of C before?
Yes.
Okay. So I'm going to put C up there. Below C, I'm going to put C++. Below C++, I'm going to put Java. And now I'll finish drawing this guy out just so we have the big picture, but then we're going to go back later and we're going to kind of fill in this history, like how we got down this pipe. But for me to explain primitive types, I want to show at least where it came from, and then we'll backtrack and fill in the gaps. So from Java, we had a little boggle over here. I went to C#. Have you heard of C#?
Yep.
Okay, so punchline here is Java. Do you know who made Java? What companies?
I don't. I'm gonna take a guess.
Okay.
Microsoft.
No. Oh man, he would have loved you. Microsoft would have loved you. So and you'll understand why in a second. I'll just tell the 30-second version of the story later on. I'll talk about the deeper history of it. But Java was made by a company called Sun Microsystems, that is now called Oracle. Okay, have you heard of Oracle before?
I've heard of Oracle.
Okay, a lot of people don't realize Oracle has anything to do with Java. Oracle, you see their cool logos and stuff like that, but even in the technology world, most people don't know what Oracle actually does. Oracle makes a database management system called Oracle. So, for instance, Amazon.com uses Oracle as their database for storing their data because it's very fast for doing enterprise speed transactions and that kind of stuff. Okay, but before Oracle purchased them, there was a company called Sun Microsystems, also a very famous company, that came up with Java. They did some other things, but let's just say Java was their big invention. Well, Microsoft tried to steal it. So Microsoft back then came out with a language called J++. That was Java syntax, but in Microsoft's Visual Studio computer program thingy. All right, so the punchline here is that Microsoft's kind of their business model is to steal stuff from somebody else, get sued, settle with them outside of court, and now Microsoft still has the technology because that's often cheaper than to come up with the technology on their own. And this isn't really to demonize Microsoft. That's really an approach that a lot of big companies have. That's why you see in the news now big companies tend to absorb other companies. It kind of makes sense.
Yeah.
And there's a kind of an interesting backstory I'll tell in a little bit or next time related to Apple. That's kind of similar along those lines. But in any case, Microsoft stole from the wrong person in this case, right? They were expecting to steal Java, have Sun Microsystems roll over, play dead, or pay some fee. Sun Microsystems wouldn't have any of it, so they sued them. Microsoft lost. Then Microsoft came out with C#. So C# is a lot like Java. If you know Java and you see C#, these languages look incredibly similar. Now you might say, okay, well, is that a problem? Shouldn't that have been illegal too? But you know what? Java looks a lot like C++, and C++ looks a lot like C, because all of these modern languages took their cues from C.
Yeah.
Okay, so just to kind of finish drawing our little picture here, I'm going to put over here Objective-C. Okay. So really, this is Microsoft wants C++, Apple wants Objective-C. And then I'm going to put something else down here called Swift.
Yep.
Okay, and you've heard of Swift?
Yep.
All right, so what is Swift? What do you know about Swift?
Swift is, I'm pretty sure it's Apple.
Yep.
It's Apple developed it, right?
Yep. So now what's interesting about this, let me just connect a couple dots, because I think you're a Mac user, right?
Yep.
All right, so I think you'll find this story I think you'll find it fairly interesting. So we might not quite get to all the primitive type stuff today, but that's okay. We're still ahead of the curve for where you are. Let me try to tell the story of this slide a little bit, because I think it's pretty interesting. So we had C a long time ago, late 1960s, something like that. Then we needed something better, and we're going to talk about the details of that, but we needed an object-oriented language rather than a procedural language. That's going to turn into another one of our slides that says there are 3 kinds of programming languages. All right, so we'll add that later. Let's just talk about the high-level history here. So when we went to C++, this was during a time period where Microsoft and Apple hated each other. All right, so when Microsoft adopted C++ as kind of their core language, Apple adopted something else. Anything else. It didn't matter what else it was, but Apple got involved in this project called Objective-C. So C++ is an object-oriented version of C. Objective-C is an object-oriented version of C. They look somewhat different, but they are both based on C. They're both object-oriented stuff. Okay? Then, down the line here, Sun Microsystems came out with Java, and they were trying to solve the problem of platform independence, because one issue a lot of people were screaming about back then was like, oh, if we're playing computer games, especially, and these were really the Mac people doing the screaming. So if you're a Mac user and you like playing computer games, the best games came out for PC, right?
Yeah.
And when did they come out for Mac? Either never or a year or two later. So all the Mac people, which wasn't that big number of people, but they can scream pretty loud, right? So they were complaining, and that kind of got the idea going that, oh, well, maybe we need a programming language that would allow game makers or software makers, just in general, because it's not just games, it's also any sort of computer program. It very likely comes out on Windows first, and then either never comes out on or comes out far later on the Mac. But maybe we need a programming language that makes it easy to develop an application once and have it run on both platforms, Mac and PC. All right? So that was kind of Java's claim to fame, if you will. And it did a lot of things right, did some things wrong, blah, blah, blah. But Java's still around. Java's still popular. And later on, if we move on and start talking about Java in another course or something, I'll kind of get into the details of that. But suffice it to say for right now, Java was kind of the upgrade to C++. Took a lot of the things that were wrong with C++ and let's just say kind of fixed them-ish, but then introduced some other issues. All right, well then I just mentioned the little fiasco between Microsoft and Apple. Microsoft and Sun Microsystems here with the Java C# war. Okay, so what came out of that was C#, which turned out to be a really, really good programming language and really good for industry. So it fixed some stuff that Java did wrong and also took a lot of the stuff that Java did right. And now both of these are very viable languages. And there's actually kind of a funny slide we can talk about related to that when we get to talk about Java stuff at some point. Okay, but the interesting thing over here, since you're an Apple person, and I'm a both person, so I'm talking to you right now on a MacBook Pro, but I also run PCs and stuff. So, I'm good with all of them. They're all corrupt companies, so just pick your allegiance and run with it. But a long time ago, Apple went with Objective-C.
Yeah.
And to this day, Objective-C is probably among my favorite languages. But it's probably also one of the most intimidating languages to initially look at. Because it really does look very different than these languages over here. So when you are just starting it, that can initially be intimidating because there's a visual difference that can be just makes you nervous. Yeah. So for years and years and years, Objective-C was the language that Apple people would use, including, the first many years of writing apps for iPhone was Objective-C. In fact, that's when I first learned Objective-C was, 11 or 12 years ago when I wrote my first app. When the App Store first went live on iPhone, I had to go and learn Objective-C. And then, I kind of really like the language, and I actually use it fairly often when I teach programming now because it shows some things that you don't get to see in other languages, that other languages hide from you. All right, but regardless, about 3 or 4 years ago, I guess, Apple came out with Swift. Now, Swift does not look like Objective-C. Swift looks like Java and C#. Okay, now this is kind of a cool punchline here. And that punchline is that no Apple developer was complaining about Objective-C.
Yep.
Okay, if you're an Apple developer, you're already drinking the Kool-Aid. All right, you're already drinking it. Okay, so nobody was complaining about Objective-C. Apple, when they released Swift, kind of set it under released it under the guise that, oh, well, our developers deserve a new language, blah, 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 right?
Yep.
Like I said, Swift looks a lot like these guys over here. Now, I mentioned a few minutes ago that Java is the main language used for writing software for Android.
Yep.
Right? And what is Android?
Android is Google owns Android, and it's basically almost every other phone besides.
Yeah, it's the iPhone's main competitor, right?
Yeah.
Okay, so you have iPhone running iOS, and then you have all the other phones,
Yeah.
almost all the other phones running Android.
Yeah.
So, and that's where numbers get a little skewed when you look at the number of people that have these different phones. There are far more physical Android devices in the wild than there are iPhones. But there's actually far more iPhones running recent software than there are Androids. So, for instance, the most recent version of, actually, two versions ago of Android is called Oreo. Okay,
Yeah.
so that is a piece of software that was released almost 2 years ago. Is Oreo? What percentage of Android phones do you think Oreo is currently installed on?
Of all phones?
Of all Android phones, and this is an operating system that came out 2 years ago.
6%.
Yeah, you were guessing low just because you thought it was going to be low, right?
Yeah.
Okay, you didn't guess low enough. It's less than 1%. Less than 1% of Android devices are running the Android operating system that was released 2 years ago. Yep. So, because when Android comes out, it only launches initially on the Pixel phones, the ones made by Google. All the other phones have to wait for it to get ported to them because Android's open source. So every phone kind of, modifies the OS to their to how they think it should work, and they break some things, they fix some other things, stuff like that. So even if you take let's call it the most popular Android phone is probably one of the Samsung phones, right? With probably the Pixel phones being like a close second. So I was an iPhone user for years and years, for like a decade. My wife's still an iPhone user. I run a Samsung Galaxy Note 9 now. I used the Note 9 last year, or Note 8 last year. And they're both fine. So I don't have a preference between the two of them. I like the giant screen on my my Note 9 and the huge battery, and I'm a big person, so it doesn't matter how big the phone is, but I like both devices. They're fine.
Yeah.
So this Note 9 literally came out, 2 months ago?
Yep.
It is not running the latest Android operating system.
What?
It's running 8.1, which is the latest version of Oreo, but now you have Android 1 that's been released that's running on the Pixel devices. So this is a $1,500 cell phone that came out 2 months ago that is not running the latest Android software, and likely won't get it for at least 7 or 8 months, is my guess.
Gosh.
All right. So that's kind of an interesting difference between iOS and Android, is when you compare these different devices, you're really looking at which phones are running the latest software that can likely run the latest apps. So for a long, long, long time, you don't hear the Android people talking about how it's more the App Store, the Android developers at least, talking about how the Android App Store is more profitable than the iPhone App Store. You can make a lot more money on the iPhone App Store than you can on the Android one, because typically the users are more affluent and more people are running recent versions of the software so that your apps will actually run on them. So just kind of an interesting side thing. But, in most arguments, I think you could probably just say that by today's standard, iOS and Android are pretty much 50-50. I think that's a fair enough assessment. For a long time, Android was a significantly worse product. But it's grown over the years, and now it's a true competitor. And we're going to kind of move towards that argument. So we're going to put 2 placeholder slides in here as a starting point. So I'm going to say iOS versus Android, like we're starting to talk about here, but I'm going to talk about something else before that. We're going to talk about Apple versus Microsoft. Okay?
Yep.
So, how do Apple and Microsoft differ?
Well, Microsoft made the first laptop computer.
Okay. Microsoft doesn't make a lot of hardware.
Yep.
So, Yeah, they didn't. They wrote the software for the first laptop computer.
Oh.
Okay, so Microsoft's a software company, right?
Okay.
So Microsoft makes software
Yep.
that runs on other people's hardware. And any hardware that you see that has Microsoft labels on it likely was a company that Microsoft acquired that sells hardware.
Yep.
You know, so you can buy like Microsoft keyboards and things like that, which are fine. I mean, that's not demonizing Microsoft. That's just saying that's how it works. They write software. That's how it works.
Yep.
Apple makes software that runs on their own hardware. Okay.
That's why they're worth $1 trillion.
Okay. Well, so I'm just gonna give you fair warning here. I'm gonna trick you in a minute.
Yep.
Okay. So be prepared. Be on the lookout. All right. So we would say that Microsoft is impressive because it writes software that runs well on hardware that it has no control over.
Yep.
Okay? Now, a lot of people will, a lot of Apple fanboys might say that, well, I go with Apple stuff because it just works, right?
Yep.
So we might say that Apple is less impressive because they only need their software to run well on their own hardware. All right, that makes some sense?
Yep.
So in general, we would say Apple's actually solving the easier problem than Microsoft. Microsoft's solving a very difficult problem. So now we go to this route. When I say something is proprietary, what am I talking about?
I have no idea.
Okay, you've seen that word before?
I've seen it. I just don't know what it means.
Okay. Tell me about open source. Have you heard that phrase before?
Yes.
What does it mean for something to be open source?
It...
So it's the source code is freely available to the world. All right. So now I mentioned a few minutes ago that a lot of these Android devices aren't running the latest, greatest version of Android, and one of the reasons for that is Android's operating system is open source. So
Yep.
what does that mean? Well, when the new version of Android comes out, it runs as is on the Pixel devices, Google's devices. But what does Samsung do? Samsung takes Android's operating system and modifies it to be, they Samsungify it. All right. And what does HTC do? They HTCify it. Okay. Some of these things aren't going to flow off the tongue all that well. But, the punchline is that because it's open source, we don't really have a true current release of the software in all these different devices because each one of these companies is putting their own kind of twist on Android. Whereas,
Yep.
Every iPhone, within recent memory is going to be running the latest version of the operating system. Every now and then they'll cut an older model off that just won't run the newest version to get you to run back to the store and give them more money.
Yep.
But the idea is that open source means it's open to everyone. Now, in general, that kind of seems like a good thing from a technologist perspective, right?
Yep.
Okay. Proprietary means not open source. All right. So Apple has hardware and software that they keep the details of hidden. Probably not a grammatically correct sentence, but let's just roll with it. All right. So Apple is a proprietary company, not open source. Now, just a minute ago, you said open source sounds like it's kind of a good thing, right? In the tech world, we like open source stuff because it encourages innovation, right? When a product comes out that's open source, that allows other people, that allows all these developers in the world to improve upon it, ultimately producing a better total end user experience for consumers. That all sounds reasonable, right?
Yep.
Okay, so is Apple bad for being proprietary?
No.
Okay, so I was kind of an iffy no, right?
Yeah, it was like.
All right, so for a long time, so let's talk about Apple. So historically, Apple has been a proprietary company. All right. Now, if we just talk about the phrase, the word proprietary, we kind of say, well, that's kind of that's negative. That's a bad connotation. But then we say, well, Apple's one of those. I'm like, oh, okay, well, they do pretty well, so maybe it's not so bad. Okay.
Yep.
So for a long time, and well, today, you can't go out and buy a computer that runs Mac OS that isn't also made by Apple. Correct?
Yep.
So you have to go and you have to pay a premium for an Apple-made computer to run Mac OS.
Yep.
But if you want to run Windows, aren't there a whole bunch of different companies that make computers that will run Windows?
Oh yeah.
Oh yeah. If you want to run iOS, don't you have to go buy a phone from Apple that will run iOS? What if you want to run Android?
You go. I mean, most phones.
Yep.
Most of the rest of the phones.
Tons of different companies will run the Android software, right?
Yep.
Okay, so really, Google today is solving the old Microsoft problem, where Apple today is solving the old Apple problem. So Apple used to write operating systems for their own desktop computers. Now they're writing operating systems for their own smartphones.
Yep.
Now, in general, we would say, well, maybe being proprietary is kind of bad.
Yep.
All right, so who's Steve Jobs? You heard of that guy?
Yep.
Okay, who besides being a dead guy now, who is he?
He's the co-founder of Apple.
Okay, yeah, very politically correct of you. Okay, do you know what the other guy is? Who is the other co-founder?
I always get his last name wrong. Steve Wozniak.
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 Yeah, Steve Wozniak. All right, so fair enough. So Steve Jobs, we'll say co-founder of Apple.
Yep.
All right. Did you know that Apple fired him?
Yep.
Okay, what was that all about?
I just watched the documentary. I'm trying to think. I think.
I'm about to teach you something that you didn't see in the documentary. That's kind of a tech secret.
I don't know.
Well, Apple's sales were going down, right? This was during a period of.
Yep.
This is when Microsoft was in its heyday. Right? Microsoft was just printing money. Money was flowing in the doors at Microsoft. Billions and billions and billions of dollars. And Apple, wasn't doing as well. It's not like they weren't doing well as a company. They were just losing the computer evolution war to Microsoft. And kind of an interesting thing that the documentary probably had in it is Steve Jobs went to the CEO of Pepsi at the time.
Yeah.
And, the kind of a famous quote, he said, do you want to change the world? Or do you want to change the world, or do you want to sell sugar water the rest of your life? Kind of a famous quote. So he got that guy onto the board at Apple, and that guy turned around and got Steve Jobs fired from his own company. Okay? Because Apple is a publicly traded company. Right? So the board has the right to fire him. So they fired Apple.
Yep.
Or they fired Steve Jobs.
Yep. Yes, I did know.
Did Apple rehire Steve Jobs?
Yep.
No, they did not.
Wait. Well, after.
Nope. He was never rehired by Apple. All right, I'll tell you the punchline here in a second.
Wait. So the documentary was lying.
Nope. They just left out a little connecting piece there. What did Steve Jobs do while he was fired from Apple?
Oh, he started the company Next.
Okay.
I think it's called.
Started Next Computers.
Yep.
Anything else? Do you know who George Lucas is?
No. Don't think so.
Star Wars guy.
Mm-hmm.
Okay, George Lucas is the guy who produced Star Wars. All right.
Yep.
Um, So at the time, George Lucas was going through kind of an expensive divorce, as a lot of these celebrities do, right? And he needed some money back then, and he sold a company to Steve Jobs.
Yep.
And it's probably not a company you've heard of. Do you know what company it is?
No idea.
Heard of that one? Pixar?
Oh, wait. Yeah, I do know what that is.
Yeah, so he sold Pixar to Steve Jobs for something in the ballpark of like $7 million.
Yeah.
Pixar, years later, Steve Jobs sold Pixar to Disney for something like $7.5 or $8 billion. And he still remained the head of the board on Pixar. So that was a pretty good investment. Okay, but from our point of view, the important thing was that he started Next Computers while he was fired from Apple, right?
Yeah.
All right. So now, what happened to Apple during Steve Jobs' absence?
I feel like they fell even more.
Oh yeah, they basically almost failed as a company. Okay.
They only have like 1%, something like that, of the market.
Well, yeah, but that's really was true for a long time. It's still almost true today. I mean, you could say Apple's way more popular today than it's been, ever been. But what percentage of desktop computers are running Windows versus are running Mac OS?
Yeah.
It's still like 96% Windows. It's not a close race when you think about computers that have this stuff on there. Apple has just created a closed ecosystem that works for a lot of people.
Yeah, but like from one company to another, like from like Apple to Linux.
Oh, sure.
Yeah.
So, for a long time you had Microsoft with 99% of the market and everybody else sharing the other 1%.
Yeah.
So Apple was the top of the second placers, the top of the rest, or something like that.
Yeah.
All right. But during this time when Steve Jobs was gone, as the Apple was trying to reinvent themselves, they decided to allow other companies to make Mac clones. Huge failure.
Yeah.
For Apple. We talked a little bit ago that Apple they write software for their own hardware, and they charge a premium for their hardware because it's the only hardware that will accurately run their software, right? So if you like Apple software, then you need to pay a premium for Apple hardware. And then the idea is everything just works together because Apple is solving the easier problem of making software work for their own hardware.
Yep, like
right?
end.
Yeah, so this was a big no-no for Apple that they went and did this. So they started sliding backwards even more. Okay, because now, at the time, Apple was running what are called PowerPC chips. Okay, so that is not Intel. Okay, so they were using another kind of processor, not an Intel processor, called PowerPC that was made by IBM. All right, so we're going to say that Apple almost failed as a company. Now, back on this slide here, we mentioned that, the Steve Jobs did this stuff. On this slide here, we said, did Apple rehire Steve Jobs? And we're just going to put a big no right here. And then what I'm going to say over here is last ditch effort. Apple acquired a company called Next Computers. So Apple acquired a company called Next Computers, which came with its CEO, Steve Jobs, who Apple then appointed their interim CEO, affectionately called the iCEO, years later. All right. So, what did Steve Jobs do during that time? Well, he personally made Apple's payroll, first of all. So, he kept Apple afloat out of his own pocket for a period of time. And then he started having a couple of wins, right? We had things like the iPod, the iMac, the iBook, which actually has gone away. That was their original laptop. It was kind of a cool laptop. It's like a really colorful clamshell type laptop.
Yeah.
iPhone, iPad, OS X.
Yep.
All right, so OS X. Now, this is kind of an interesting thing with Apple as well. Apple almost failed multiple times after Steve Jobs came back.
Yep.
So, for years and years and years, the Apple fanboys were saying, well, Mac OS is way, way better than Windows, and the reality is that just was not true.
Yeah.
It just flat out was not true. The Mac OS was just an antiquated piece of crap, is what it ultimately was. When they moved to OS X, this was actually a really good product, and it should be, because OS X is based on top of an open source operating system called OpenBSD Unix. And Unix is a very stable operating system that's been around for years and years and years and years. And what did Apple do? They stole that operating system. Well, it's not really stealing because it's open source, but they took that operating system and then they put a front end on it that made it look pretty, made it feel like a Mac. Okay? And that was called Aqua in the early days.
Yep.
So they released this operating system, but now we have one problem. This is actually related to what we talked about last week. Remember we looked at that low-level code, the Hello World code written for Linux? And I mentioned that it actually had power tools in it. So, even though it seemed like it was really complexy looking code, we were actually using system calls that were part of the Linux API for actually telling it to put stuff on the screen and stuff like that.
Yep.
Okay. Well, Apple, their operating system up to that point, so the last operating system was OS 9, had the Mac OS system calls. Now all of a sudden, their software architecture is now a Unix-based operating system. So it had what are called POSIX system calls, not compatible with Mac OS system calls, which means the software that ran on Mac OS 9 would not run on Mac OS X. So all those computer programs that you had yesterday, when you got your brand new Mac today, could no longer be run. Make sense?
Yep.
Okay, so Apple came out with these computers that were running this brand new awesome operating system that had no software that would run on it, or very little software that would run on it. So that operating system actually shipped with something called the Blue Box. Are you familiar with VMware and Parallels? Have you heard of those products before?
No.
Okay, so on a Mac, you can run VMware Fusion or you can run Parallels that'll let you run Windows on the Mac.
Oh, yeah.
Okay, you know what I'm talking about?
I've actually seen people run Mac on Windows.
Yeah, it's called. There's a project called Hackintosh that it'll work, but it's kind of sketch. You're not going to have a real stable experience. But if the spirit's willing, you can make it work, type thing. But in any case, when Mac OS X came out, it shipped with a virtual machine called the Blue Box, which allowed you to run OS 9 inside of Mac OS X, so that your programs that you had would still run, albeit really, really slowly, inside of a virtual machine, while you waited for those programs to get ported over to Mac OS X. And most of those companies then charged you for that software again so it would run on your new computer at full speed. Okay? So that seems like it was a big problem, a big risk that Apple took, right?
Yep.
And they survived it. So they got through that. The operating system was good enough. It was such an improvement that it was worth those growing pains. And then a couple of years later, Apple did it again. Apple switched from PowerPC processors to Intel-based processors, which now means that they had to rewrite OS X to run now on the Intel processor rather than on PowerPC, and all the software that used to run on the PowerPC version of OS X no longer ran on that. You had to wait for it to get ported over to the Intel version of OS X. So Apple actually survived it twice.
We're probably going to have to do it a third time.
Well, so I'm going to show you in our last minute here. I'm going to show you an interesting piece of evidence. I'm going to bring it up on my screen here. I'm going to show you some Apple documentation for their current programming languages. Okay, now this is Swift. I got to change the way I'm sharing my screen here. Hold on. So this is going to be the evidence of everything that I've told you up to this point. So we said that a little bit ago that Swift is actually, very new, right? Only from like 3 or 4 years ago. So this is class bridges for Swift. So this is Swift documentation on Apple's developer page, right?
Yep.
Okay. So when you want to create a string in Swift, the name of the class is called NSString. Next step string. This is Next Computers. So what we see as Apple today is actually Next Computers with an Apple logo on them.
What?
Apple died 15 years ago. Nobody noticed.
What?
And there's your evidence right there. This is modern documentation for a programming language that came out 4 years ago. Did your documentary cover that?
No.
And it's right there in their own documentation. Yeah, so it's now, I mean, that's more of interesting trivia stuff, right? You can go all the way back to the beginning and say, really, what was Apple? Apple was Steve Jobs and Wozniak, right? So wherever they were, that's where Apple was. Okay, so even though he came back, he brought Next Computers. I mean, Next Computers never took off in and of itself. So what you really needed is you needed Apple's branding with Steve Jobs', let's call it eccentricity, along with a better technology, and that's what Next Computers brought to the table.
Yeah.
It brought a step in the right direction to better technology that then needed the Apple polish, and it needed Steve Jobs attached to that to make it flourish. So Steve Jobs was a lunatic, but I think it takes people like that to change the world the way that some of these guys have. There's, if you read his biography that came out a couple of years ago, it talks in there about all sorts of problems he had with his kids and not being a good dad and all this stuff. I mean, so there were consequences to some of the things that he did, but, I think he was also a major, major part of what made Apple special. And now we're seeing it over the last several years. Well, Apple, obviously is more profitable now than it's really ever been, being $1 trillion company, but certainly they've lost their shine, right? So just because they're being profitable as a company, we're kind of less impressed, less excited about every new product they announce. It's lost some of its glimmer. Where when Steve Jobs would come out on stage, we were always excited about what he was going to say next, that type of thing. Make some sense? Okay, so let me save the PowerPoint here real quick so the link will update for that. And let's see if Vincent has next week's assignment already up. I don't see it yet, but I'll follow up with him later on today and make sure that he gets that up. And then are we on for same time, same station next week?
Yep.
All right, let me just confirm on my calendar real quick that I don't have a conflict. Yep, that looks good. So, what is that? 7 p.m. your time, 6 p.m. my time next week.
Yep.
Okay, well, I will see you then. And as always, if you have questions about the homework assignment after he puts it up, message me on Slack and I'll get back to you and then we'll go from there. Sound good?
Yep.
All right, I'll see you next week.
All right, see you. Bye.
All right, bye-bye.